Good day, everyone. So, our lesson for this day is all about evaluating algebraic expression. So, before we start this lesson, here is our intended learning outcome or the ILOs. At the end of the lesson, the um, BIS INT students should do the following. First is differentiate algebraic expression and um, algebraic equation. Second is evaluate algebraic expression. Third is enumerate the laws of exponents. And fourth is simplify problems using laws of exponents. Again, so here is the intended learning outcomes for today. At the end of the lesson, the students should be able to do the following. First is differentiate algebraic expression and algebraic equation. Second is evaluate algebraic expression. Third is enumerate the laws of the exponents. And fourth is simplify problems using laws of exponents. So, expression. So, when we say expression, it has not an equation. It is not an equation because it does not have any equal sign. So, there are two types of expression. First is numerical and algebraic. When we say numerical, so numbers ra jud siya. When we say algebraic, naa na siya kauban variable. And again, there are two types of expression. First is numerical and then second is algebraic expression. So notice, there are no equal signs in these expressions, so they are not equations. So, but when we say algebraic equation, we are using equal sign. So again, when we say expression, wala equal sign. And then algebraic equation, it is using equal sign. So, expression. A numerical expression contains only numbers and symbols and no letters. If when we say numerical expression, numbers ra jud siya, walay letters or variables. So for example, 5 times 3 plus 8. So we can use this one, 5.5 times 3 plus 8. So that is considered as numerical expression. And the next is when we say algebraic expression, it contains only numbers, symbols, and variables. So it is also sometimes referred as variable expression. That is algebraic expression. So for example, the product of 3 and the number, so 3x. The sum of an m and n, m plus 8. The difference of r and 2, so r minus 2. So as what you can see, it has a number, symbols, and variables. So that is considered as variable expression. So what is variable? When we say variable, it represents a known value. A variable can be any letters of the alphabet to represent the known, but commonly uses the letter x, y, and z. For example, number 1, 4 plus x. X is considered as a variable. And the number 2, 5y. So y is considered as variable. So again, when we say variable, it represents a known value. So usually, we use the letter x, y, and z. So word phrases for multiplication are the product of 5 and a number, so 5x. So product means it's multiplication. And then 7 times a number, 7y. So times means multiplication. 5 multiplied by a number, so 5z. So multiplied is multiplication. So meaning that there are also phrases in operation. So for example, addition. So when we say addition, we are using sum. And then when we are using subtraction, we are using the phrase difference. And when we are using division, we are using quotient. So meaning there are word phrases in operation. So always write the variable after the number or constant. So meaning, first, ay butang nimo ang number or constant, and then after that, the variable. Dili jud maguna ang variable. So, for example, 5x. Walay mahitabo na x5. Kay ang ibutang jud na ang constant, and then after that, the variable. And then evaluate means to find the value of an algebraic expression by substituting the numbers in four variables. So you are evaluating an algebraic expression which you are substituting a number from a variable. So for example, 6 plus m. So if m is 2, what is the value of m? So 6 plus m, so 6 plus 2. So 6 plus 2 is equals 8. So thus, the answer is 8. So meaning, if m is 2, the answer is 8. Another example, 7 plus r. If r is 3, what is the value of m? So 7 plus r. 7 plus 3. You are substituting 3 from r. So 7 plus 3 is equals to 10. So thus, the answer is 10. So that is evaluating algebraic expression. Next is exponent. When we say exponent, it is multiplied by itself. Any number multiplied by itself, it's considered as exponent. So there are laws of exponent. So here, first we need to define first the exponent. So 7 squared. So when we say base is 7. So muna siya ay base, and 2 is the exponent. And then overall, 7 squared is considered as power. So for example, so you need to consider the power, exponent, and base. For example, 5 raised to 4. So 4 is the exponent, 5 is the base. 8 raised to 3. 3 is considered as exponent, and 8 is the base. X raised to 7. 7 is the exponent, base is x. Y raised to 5. 5 is the exponent, and then y is the base. A raised to n is the exponent, a is the base. So, the first law of exponent is the product law. When you say product law, for example, a raised to m, a raised to n is equals to a m plus n. So, if you are multiplying the same base, parehas og base, and then different exponent, you need to add the exponent. When multiplying two powers with the same base, just add the exponent. For example, a raised to 3 times a raised to 2. The answer is a 3 plus 2. So the answer is a raised to 5. That is product law. And then x raised to 3 times x raised to 2 times x raised to 5. It is x 3 plus 2 plus 5. X is equals to 10. So you need to just sum the exponent or add the exponent. Dapat i-plus ra nimo exponent basta parehas sila og base. The next is quotient law. When we say quotient law, a raised to m divided by a raised to n is equals to m minus n. When dividing two powers with the same base, just subtract the exponent. So if you will divide the two powers with the same base and then different exponent, you need to subtract the exponent. For example, a raised to 3 divided by a raised to 2 is equals to a 3 minus 2. So 3 minus 2 is equals to 1. So a raised to 1 or a. So the answer is a. And then another example is x raised to 3 divided by x raised to 4. So 3 minus 4 is negative 1. X raised to negative 1 or 1 over x. Basta na ay ma-negative ang exponent, you need to give the reciprocal by itself. So that's why x raised to negative 1, the answer is 1 over x. Next is the power law. When we say power law, a raised to m times n is equals to a mn. So if you have a power and then gihatagan siya exponent, you need to multiply the exponent. So to simplify any power of power, simply multiply the exponent. So for example, a raised to 3 times gi-raise pa jud 2. So the answer is a 3 times 2. So the answer is a raised to 6. X raised to 5 and then the raise pa jud 2. So the answer is x 5 times 2. So the answer is x is equals to 10. That is considered as power law. And the next is powers with different base. Kung lahi sa lahi silang base, but then the same ang exponent, you need to just you need to dapat itapad ra nimong base and then erase. For example, a raised to n, b raised to n is equals to a times b raised to n. Like for example, a squared, b squared. So parehas man sila exponent. So the answer is ab raised to 2. x4, y4 is equals to xy raised to 4. Then next is powers with different base. So an divided by bn. So is equals to a over b raised to n. So if parehas sila og exponent but then not the same ang ilahang base. So pwede na nimo ma-simplify. Dividing different bases can't be simplified unless the exponent are equal. So kung lahi-lahi siya og base but then parehas og exponent, you can simplify it. And then you can use powers with different base. For example, a squared divided by b squared. So you can simplify it by a raised over b raised to 2. X raised to 4 divided by y2 raised to 4. So x over y raised to 4. That is powers with different base. And the next is zero exponent. When we say zero exponent, so a raised to 0 is equals to 1. Any base raised to 0 is always 1. Bisan og 1 million raised to 0 pa na siya, the answer is 1. 1 billion raised to 0, the answer is 1. A non-zero base raised to 0, a zero exponent is equal to 1. So for example, a raised to 0 is equals to 1, b raised to 0 is equals to 1, x raised to 0 is equals to 1. Next is negative exponent. So a raised to negative n, so is equals to 1 over raised to a raised to n. A non-zero base raised to negative exponent is equal to the reciprocal of the base raised to the positive exponent. So meaning, if ang exponent is negative, you need to give the reciprocal of the base. So that's why a raised to negative n is equals to 1 over a. For example, ganiha, x raised to negative 1, so the answer is 1 over x. Kaya reciprocate man siya. So that's all, and thank you so much.